Have you ever clicked a button in your app and everything just stops responding? It's not crashed, it's not slow, it just freezes. Let's quickly investigate what happened with an example. Imagine your app is a restaurant with only one receptionist. Each customer is a task your app needs to handle. This means services will be slow when more than one customer is simultaneously placing orders. Now, the situation we have here are two things. We have the receptionist, and then we have a long line of customers here. Now, each one of these needs to be served by one receptionist right here. But this receptionist cannot multitask by serving two or more people at the same time. And there is always a possibility that customers will become impatient, some will walk out, and some will start complaining, and then the receptionist will get pressured. Now, this particular customer, the first one here, has placed an order. And as expected, sometimes orders at restaurants take time because they have to be processed. The receptionist must wait. The receptionist here must wait and wait and wait until his order is served before this receptionist serves the next customer here and then the next. And there is a possibility that each and every one of these customers will place an order that will take time. This does not sound like an efficient process, because while that happens, everyone else is stuck, as I already mentioned. This is exactly what we mean by code blocking. When we write code and there are many tasks that one thread has to take care of, and then there is a queue, and then one blocks the other. But we have a solution. And the solution is this: async. The way async works is this: the receptionist would keep the line moving, and the way the receptionist does that is that he creates a waiting area. He instructs the stock customer to step aside, to the first customer that placed the order, to step aside to wait for his order while the receptionist attends to the next person. This is what async does. It's not like the receptionist is attending to all of them at the same time. That's not what async does. Rather, while the operating in asynchronous fashion means the receptionist, the threat handler, is it's accepting the orders from each customer, and each customer, as we mentioned, is a task, and then placing that order, and before that order is processed, he goes to the next customer. And of course, what happens next is each customer is expecting feedback, is expecting a result, whether it has succeeded or not. And this is what await does, because the customer is waiting, right, for feedback, and you have to return the result of the process that you have been awaiting. And so when our order is resolved, the customer returns and takes it or receives feedback that that maybe the food or the order he placed, or he or she places, is absent. It doesn't exist. And this is exactly what happens in software. What happens is, for instance, you make an API call in an app to get a list of items. And then it takes time, because an API call has to make a HTTP call, goes to a different site, and then fetches data from the database. And this could be slow sometimes, especially when there are many items. And so not in order to prevent the user from thinking the app has crashed or it's not functioning, you will see a loader most of the time. You'll see a loader like this, or linear or circular loaders on platforms telling you that it's fetching data. What's happening is that while it is fetching data, you as the user waits. You need to understand that another user is using the app at the same time. And so by using async and await, what happens is that the app is able to serve, the platform is able to serve different customers at the same time, and the same function is able to serve different people at the same time without mixing them up.